Okay, so today what we're going to do is look at an introduction to logarithms. Logarithms were invented so that you could do a lot more math with really big numbers, and they really equate to exponents. So you're going to see that a logarithm is really just another way of writing an exponent, but it allows you to do some mathematics that you wouldn't be able to do with exponents, particularly when there are variables inside the exponents. Okay, so first of all, we're going to talk a little bit about what a logarithm looks like and how you can change an exponential form to a logarithm. Now, this is going to be given to you on your formula sheet, but you need to really understand it to make it work for you. Okay, so in general form, bx equals y, where the b is the base, x is the exponent, and y is the answer, right? If you took the exponent. So example, 4 to the second power is 16. Okay? Standard exponential notation. Well, we can rewrite that as a logarithm as log with a base of b. Remember, the base of the exponent is the base of the logarithm. And the y equals x. So what's happening is these two, the y and the x, are simply switching positions, and the base becomes the base of the logarithm. Super easy. So for this particular one, again, the base of the exponent becomes the base of the logarithm. The answer now goes next to it, and the exponent moves. So again, these two pretty much just switch places. All right? So we're going to go through a couple of these, actually several of these, and just to be able to write them. Okay? Now, you do have to be aware of a few things, and we'll talk about those as we get there. So don't worry about those exponential forms and logarithmic forms just yet. Let's just write them out. Okay, so I'm on page 19. We're going to look at number 2. Unfortunately, I can't show you the book right now, but you've got it, so you're in good shape. So if you have 10 to the 4th equals 10,000, that simply becomes log base 10 of 10,000 equals 4. So it's just a matter of rearranging. And it doesn't change under any circumstances when all you're doing is converting from exponential to logarithmic notation. Okay? Now, you will have to change them back, be able to change them back, but again, that's simply a matter of rearranging these two and getting rid of the log, just using the base. So instead of log, we're going to have 10, so the base is still the base, 2 is the exponent, 100 is the answer. Okay, look at number 6. Log base 3, 27 equals 3. To change that, there's our base, that's the exponent, and that is the answer. Okay, so very straightforward. Practice it though, because it's important that you understand where each piece goes. It's really easy to make a mistake and get them in the wrong place. Okay, now if you look at the top of page 20, in that chart, it's talking about some tricks, and we talked about these with the exponential forms. So remember that if you have anything to the 0 power, it always equals 1. Anything to the first power is equal to the number itself. Okay. If you have a fraction that's a negative exponent, gives you the fraction. So if you have a fraction, you can get rid of it by using a negative exponent. And a fractional exponent is really a root. So you can get rid of a fractional exponent by turning it into a root, or the other way around. You could turn a root into a fractional exponent if that's easier for some reason. Okay? And you can use these, so if that, these same rules for exponents apply to logarithms. So log base 10 of 1 equals 0. That's the same as saying 10 to the 0 equals 1. Right? So, same format. Anytime you have a log where the base and its argument, that's what's called the argument there, is the same, it's always going to be 1. Now this one is really important to you. If these two things are the same, then that whole thing just turns into a 1. Okay? So be careful with that one. Right? You can have log base 2 of 1 over 32. Well, the base was a whole number, but we turned it into a fraction. The only way to turn a whole number into a fraction is if you're using a negative exponent. Okay? And you can actually change that 1 over 32 into 1 over 2 to the 5th power, which is 2 to the negative 5th power. Right? So you can see exactly where that negative 5 is coming from. Okay, so we're just going to practice a few of these. There's one more that I want to talk to you about, and that's when you just have log of a number. If you don't have any base here, because this is not the base, that's the argument. If no base, assume a 10. So like if you have that square root symbol, we don't usually write a number in there, but we know it's a 2, right? Same thing here. If we don't, if it's a log base 10, we don't bother to write the log base. We just simply write the log of whatever the number is, and we assume that the log base is 10. And that's going to come into play in one of your homework questions where you have log base 10 of 10. Remember, that's the same as having the 2 be the same, so that's going to turn that automatically into a 1. So keep that in mind as you go, that if there's no base, you assume it to be a 10. Okay, let's just do some of those that are on page 20 there. I'm just going to do some of the even ones. 5 to the first equals 5. We're going to write that in logarithmic form. Okay, so it's log base 5. Oops, sorry. Log base 5 of 5 equals 1. And again, we knew it was going to equal 1 because those two things are the same. But again, all we're doing here is converting these, not solving them. Right? Look at number 6. 10 to the negative 2 equals 0.01. Any negative exponent is going to give you a fraction. And again, a fraction is just a decimal is just another way of writing a fraction, right? So we're going to get log base 10, so I don't care. I don't have to write it, of 0.01 equals negative 2. Okay, in logarithmic form. Now again, notice, it was base 10, so I didn't bother to write it. Okay, look at number 10. 8 to the negative 1/3 equals 1/2. So that gives you log base 8 of the 1/2 equals negative 1/3. Okay. All right. Okay. And then if you can look, they're just having you write some in exponential form. So again, changing a logarithm to an exponent, practicing that. But if you look at number 11 on page 20, what they want you to do is match them to their correct value. What they've done is they've simply put the logarithm into the calculator. So you're just going to use your calculator. And again, just Google it if you don't know the right steps to push in your calculator, because you're using a Casio, and I'm sad to say that I have left my Casio at school, so that means I'm not going to be able to use it the whole time we're gone. So you look up the keystrokes for finding a logarithm. There should be a logarithm key on your calculator. So just use a calculator to get those values. Now, I do want to warn you, you only do it when asked. So in other words, don't start changing logarithms into decimal values, because they almost always have to be rounded. They're really hideous decimals usually, and so you don't want to round those if you can avoid it. Okay? Now, we're going to continue on a little bit and talk about some logarithm rules. Right? And the logarithm rules simply means what happens when you have a log plus another log, okay? And if you think about the exponent rules, they're the same as exponent rules. When do you add exponents? When you're multiplying powers with the same base, you add the exponents. So the same rule applies here. That becomes the log of A times B. Simply log AB, using the most simplified notation. Okay? Now, same thing is true. We'll go ahead and do a couple of these. So if you want to look at like number 2, log base 15 plus log base 4. Sorry, not log base 15, log base 4. Log of 15, log of 4. The base of these is actually 10. And that base must be the same. To use these shortcuts. Okay, and we assume it's a 10 because there isn't one written. So that's the same as the log of 15 times 4 which, of course, gives you log of 60. Whoops, I keep wanting to write that too high. Okay. And again, remember that there is no base there, so you assume it to be a 10. And you could put that in your calculator and evaluate it, but again, it's going to give you a really ugly decimal. All they want you to do is multiply the two things together. Okay? If you have more, say look at number 6. Log of P plus log of Q plus log of R is just log of P, Q, R. All of them multiplied together. And again, because there's no base, you assume it to be a 10. And I keep saying that because it's really important. Okay? Now, the other rule talks about what happens when you subtract logs. So log of A log of A minus log of B. When you subtract exponents, that's when you're doing division with exponents, right? So that simply means the log of A divided by B. Let me write that a little better. Okay? All right. So, and of course you can combine those two operations. So if we have log of 15 minus log of 3, that becomes the log of 15 divided by 3, which is the log of 5. Okay? And again, you can have more than one operation where you have to do multiplication and then division. So look at something like number 6 with the log of f plus log of g minus log of h simply becomes the log of fg. In other words, we multiply those two together, divided by the log of h. And of course, since these two are not numbers, you can't really divide them. But if they were numbers, you could go ahead and simplify and divide by doing the division. If you can. You can't always do the division. Okay? They have somewhere they want you to turn it around and rewrite them using addition and subtraction. So say, for example, we have log of 20 over 1, which is kind of a ridiculous one to write, but that's okay. They asked us to. They're dividing, so that means you're going to turn it into subtraction. There you go. All right? Don't make it harder than it is. Okay. Now, that's as far as we're going to go on this video. So what I want you to do is simply practice using those rules for simplifying. And then I'm going to come back and do another video for you tomorrow, simplifying some more, doing some more work with logarithms. So for homework, just complete everything from pages 19 through 21. Okay? All right. Thanks.